Good morning. Welcome to Mission Control Houston at NASA's Johnson Space Center. This is where the International Space Station's lead flight control team is on duty around the clock, monitoring all of the station's systems and assisting the Expedition 55 crew members as they work through their daily tasks of scientific research and space station maintenance. Well, science and maintenance were high on the agenda this week, but so were preparations to change the makeup of the crew themselves. Commander Anton Shkaplerov and flight engineers Scott Tingle and Norishige Kanai are about ready to hit the door, headed for home after almost 6 months in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Haley Fick. This week we'll officially bring one expedition to a close and welcome the beginning of another. Expedition 55 will come to a close when Russian cosmonaut Anton Shkaplerov hands control of the space station over to NASA astronaut and Expedition 56 Commander Drew Feustel. You can watch the change of command ceremony live on NASA TV at 2:25 p.m. Eastern Time. Shkaplerov will return home with NASA's Scott Tingle and Japanese astronaut Norishige Kanai on June 3rd. A new three-person complement, Sergei Prokopyev, Serena Aunin Chancellor, and Alexander Gerst will launch from Baikonur on Wednesday, June 6th, and join Feustel's crew aboard the space station on June 8th. With the Cygnus cargo craft docked to the space station, there is plenty of research to keep the crew busy. The Barrios protein crystal growth experiment tests the feasibility of off-the-shelf equipment for growing different protein solutions at the same time, which may allow for speedy development of better pharmaceuticals on Earth. Solidification using a baffle and sealed ampules, or SUBSA, could contribute to improved technology on the ground through its experimental methods for producing semiconductor crystals. The crew also spent some time installing the cold atom lab that we learned about last week. It studies atoms in extremely cold situations, which can help scientists answer questions in fundamental physics and contribute to the development of atomic clocks and spacecraft sensors. This week, Drew Feustel and Ricky Arnold answer all your questions about life in space in a special Tumblr video answer time. Hear straight from current space station residents about what experiencing weightlessness for the first time feels like, the experiments they perform, and the beautiful sights they see from up there. Check it out at nasa.tumblr.com/answertime. Keep sending us your questions using the hashtag #SpaceToGround. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
As Haley mentioned, NASA TV and NASA.gov's live coverage of the crew exchange begins later today, 1:25 Central Time this afternoon, for the change of command ceremony, as Shkaplerov hands over responsibility for the station to Expedition 56 Commander Drew Feustel. We'll be back on Sunday, June 3rd, 12:30 a.m. Houston time, to see the final farewells before the departing crew enters their Soyuz spacecraft and close the hatches on orbit for the final time. Coverage of Soyuz undocking begins at 3:45 a.m. Central Time Sunday. The actual undocking is targeted for 4:16 a.m., and that will mark the official start of Expedition 56. We'll be back at 6:15 a.m. Houston time to monitor the deorbit burn, coming at 6:57, right through landing in Kazakhstan at 7:40 a.m. Sunday morning. Looking ahead, we'll be on the air Wednesday, June 6th at 5:15 a.m. Central Time for launch of the Soyuz vehicle carrying Commander Sergei Prokopyev and astronauts Serena Aunin Chancellor of NASA and Alexander Gerst of ESA, the European Space Agency. And then again next Friday morning, June 8th, for all the details of the arrival of the new crew members to the International Space Station. On the subject of the next NASA astronaut to fly in space, you may already know that she's a doctor, a former flight surgeon, with an engineering background, an Indiana native who graduated from high school in Colorado and went off to college with an eye toward working at NASA someday. But did you know she has mismatched twin dogs, a background in martial arts, and a college baseball Jones? Here are 5 things you didn't already know about Dr. Serena Aunin Chancellor.
5 things that you probably didn't know about me. Probably number 1, our family has 2 dogs who really think they are brothers. And one is a 130-pound French Mastiff named Boss Hog, and the other is a 12-pound miniature dachshund named Oscar. And they run around together, and they think they are absolute brothers and absolutely the same, but they are absolutely the heart and soul of our family. Number 2, Our family absolutely loves to watch Aggie baseball. It's one of the favorite things that we do together as much as we can, certainly during baseball season in the spring. And in fact, it was the last thing we did before coming out to Russia to prepare for launch. We watched the Aggies play baseball at the University of Tennessee. Number 3, I actually do still practice medicine. I'm an active physician, and one of my favorite places to see patients is at a free clinic in Galveston, Texas, where we practice medicine for the underserved and those who can't afford medical care and do not have insurance, and that's at St. Vincent's House in Galveston, Texas. Completely student-run free clinic, but it's one of the joys. I love going there, and I love seeing my patients, and it allows me to teach medical students and residents really how to practice medicine in an underserved environment, and something I enjoy doing every week when I'm able. Number 4, my husband and I had a very non-traditional wedding on a 1,000-acre ranch, and part of our wedding reception, we actually had a rodeo event, and there was a big calf roping event that occurred, and most of our guests say they had never ever been to a wedding or a reception like that, but thought it was the best thing they'd ever been to. Final one, number 5, something many people do not know about me is that when I was getting my bachelor's degree at the George Washington University, I also needed to work to earn some money, and so I actually taught martial arts. I taught Kung Fu to school-age kids from age 5 to about 15. I would do that 3 times a week, and that's how I earned money in college, teaching martial arts.
As Autumn Chancellor and her crewmates get acclimated to their new home on orbit, they'll start digging in on the science activity underway in the station's several laboratory modules. And that's going to include experiments in a brand new atomic refrigerator, which is capable of cooling matter down to just above the point where, in theory, the thermal activity of the atoms comes to a stop.
Cool Science on the International Space Station. Presented by Science at NASA. NASA researchers are creating a spot colder than the vacuum of space inside the International Space Station. It's called the Cold Atom Lab, or CAL, and it can refrigerate matter to 1/10 billionth of a degree above absolute zero, just above the point where all the thermal activity of atoms theoretically stops. At this temperature, atoms lose their energy and start to move very slowly, explains Rob Thompson, CAL project scientist at NASA's Jet Propulsion Laboratory, or JPL. At room temperature, atoms bounce off each other in all directions at a few hundred meters per second. But in CAL, they'll slow down a millionfold and condense into unique states of quantum matter. CAL is a multi-user facility that supports many investigators studying a broad range of topics. Eric Cornell, a physicist at the University of Colorado and the National Institute of Standards and Technology, will be leading one of the first CAL experiments. Cornell and his team will use CAL to investigate particle collisions and how particles interact with one another. Ultra-cold gases produced by the Cold Atom Lab can contain molecules with 3 atoms each, but which are 1,000 times bigger than a typical molecule. This results in a low-density, fluffy molecule that quickly falls apart unless it is kept extremely cold. How is particle behavior affected as more particles are introduced? What can be learned about quantum objects when several atoms are interacting at the same time? Cornell says the way atoms behave in this state gets very complex, surprising, and counterintuitive, and that's why we're doing this. Cornell shared the 2001 Nobel Prize in Physics for creating Bose-Einstein condensates, another state of quantum matter that can be studied inside CAL. Bose-Einstein condensates are essentially blobs of quantum matter that look and behave like waves that exist at these ultra-cold temperatures. In the free fall of space, the condensates can hold their wave-like forms for 5 to 10 seconds, much longer than on Earth, providing researchers a window into the quantum realm. Thompson says we can use CAL to test general relativity and quantum mechanics. One of the biggest questions in physics today is how those two work together. University of Rochester physicist Nick Bigelow and University of Berkeley scientist Holger Mueller, along with their colleagues, plan to use CAL to test a cornerstone of Einstein's theory of relativity, the equivalence principle. which holds that gravity and external acceleration cannot be distinguished experimentally. They plan to repeat Galileo's iconic experiment dropping cannonballs off the Leaning Tower of Pisa, but using atoms instead. Dropping atoms inside Cal and letting them fall for several seconds as the station orbits Earth will allow researchers to precisely figure out the differences between how the atoms accelerate. This experiment may reveal how gravity and spacetime are woven through the quantum realm. A researcher at JPL named Jason Williams also plans to use ultra-cold two-atom molecules to develop tools for the next generation of precision gravity tests with quantum gases. Many more experiments are planned for this cool new laboratory, and no one knows where they will lead. With Cal, says Thompson, we're entering the unknown. For more from the International Space Station, visit www.nasa.gov/station. For cutting-edge physics on and around Earth, stay tuned to science.nasa.gov.
Flight engineer Norishige Kanai spent some of his time this week talking with students on the ground in Japan. It's the kind of engagement that's common for station crews to do during this year of education on station. Astronaut and former teacher Joe Akaba was on orbit for expeditions 53 and 54, and now astronaut and former teacher Ricky Arnold has taken over for expeditions 55 and 56. NASA has activities planned for this year with a teacher on board to help students and their teachers on Earth get the most out of learning about science, technology, engineering, and math. And that includes a series of STEM-monstration videos. In this one, Joe Akaba talks about exercise on orbit.
Hey there, my name is Joe Akaba, and I'm living and working on the International Space Station as part of Expedition 53. One of the best parts about living on the space station is being able to float. Just like you walk from place to place throughout your day, we float from place to place throughout our day. However, we have learned that the same thing that allows us to float, microgravity, is hard on our bodies over time. Our muscles and bones are made of millions of tiny units called cells, and these cells can have problems in microgravity. Up here on the station, bones and muscles no longer have to support the weight of our bodies, so they get weaker. Astronauts could develop something called muscle atrophy, where our muscles become weak from lack of use. Each bone in your body is made of cells too. A healthy bone has more density than an unhealthy bone. Weakened bones can lead to a disease called osteoporosis. Fortunately, our scientists at NASA have figured out one way to keep astronauts healthy and strong. It's called exercise. Let's take a look at how astronauts exercise in space. This machine here is the Advanced Resistive Exercise Device, or we call it ARED. It simulates free weight exercises in normal gravity to work all of the major muscle groups. ARED's primary goal is to maintain our muscle strength and mass so that we have less of a recovery period when we land back on Earth. All right, so there's looking at lifting. But what about a little cardio? We have a treadmill for that. Let's check it out. Staying physically active helps both astronauts in space and humans on the ground to stay healthy. And it prevents muscle atrophy and osteoporosis. Now you can try the activity connected to this video to learn more about muscle and bone cells. I'm Joe Akaba, and I hope you enjoyed learning about exercise on the International Space Station. We'll see you next time.
International Space Station crew members spend more than 2 years training for these missions. For those of us who have a little less time available for study, the crew has provided some quick lessons about how things work on this vehicle. In this Speedy Time segment, astronaut Peggy Whitson pulls a rack out of the wall of the Destiny Laboratory to show us how astronauts work with the Microgravity Science Glove Box, a sealed environment where they can perform science and technology experiments that involve potentially hazardous materials.
Today, we wanted to talk to you about Microgravity Science's glove box. We do all kinds of experiments in here. I've grown tissue culture cells. I've looked at how air and fluid separate. I've grown superconductor crystals in here, and they got up to over 700 degrees Fahrenheit. So this environment was to protect us from what was happening inside the experiment. Now I'm growing cells, and they have to be grown in a sterile environment. So now I'm protecting the cells from me by having them inside this environment. So it's very flexible, and we can change out all the experiments by opening up this big door on the front. Then once we've got the experiment set up inside, you can access from the sides, or we have this little airlock down here that if you wanted to, you could access from here as well. It's kind of like a transformer. At the end of the day, when you're done working with it, you just push it back into the rack. There we go, and it fits right in very nicely within the rack volume. The other thing that goes along with this, or is attached to this, is a microscope. We have a fantastic microscope with capability to send the videos and pictures down to the ground. The ground's been looking at the structures that are forming differently here in zero gravity. That's why they're doing the research here, is to see what new they can discover. So very cool science, very cool piece of hardware. Microgravity Science's glove box.
Now, you probably don't know what you'll be doing 6 months from today, but the schedule for the International Space Station crew members is plotted out that far in advance, all thanks to a group at NASA's Marshall Space Flight Center in Huntsville, Alabama. Take a look at how these men and women map out science activity for the crew in space to support the cutting-edge research now underway.
Basically what we do as a planner is we get to tell the crew what to do. We put together what's called an OOS, an OOS, which is On-Orbit Operations Summary, and it's a 6-month plan. It's the entire mission. It includes NASA, ESA, JAXA, and Russia and Houston. So everybody has something that has to go into this 6-month plan. Then we get into the WLP, or the Weekly Look Ahead plan phase, and that's 2 weeks out. So what we do is we take a week out of that 6-month plan, and we plan it a week at a time. Then we break that week into days. So 2 weeks out, we're doing the weekly plans. 1 week out, we're doing the daily plans. Then they execute the next week. That's one of the things that we come across is things break. There's replanning that goes on, like the timeline change officer, one of our planning positions in the front room. That's what they do. You know, if the timeline goes up in smoke, you know, they've got to replan for the next day. That's the coolest thing, actually, to look up on NASA Select or look up on TV and it's like, hey, I planned that, I did that, you know, so that's a cool feeling. We are snackaholics, so you will not starve in the planning room, that's for sure.
Bring you food and we'll get your payload on the timeline.
Please feed the planners.
While some experiments are at work inside the International Space Station laboratories, there are cameras on the inside and outside of the station that are collecting imagery to fascinate the human eye. For example, this 4K video, it was shot in August 2016 as the station traveled nearly 1,000 miles, taking in views from the western coast of France all the way to the Balkan Peninsula. The International Space Station is a crucial stepping stone to future deep space exploration, and it also serves as a unique science platform, enabling researchers from all over the world to conduct innovative experiments that they couldn't do anywhere else. Each of the station's partner space agencies has distinct goals for their space research, but they all share a goal of extending the resulting knowledge for the betterment of humanity.
It's a big, beautiful blue planet, and the adventurous natives have been exploring it all over from the very beginning. Lately, they've been exploring off the planet, determined to discover what's out there. But as luck would have it, their pursuit of their future has also been building their present. They're enjoying benefits today that are coming out of the work about tomorrow, work that's being done right now, aboard the International Space Station. Since Expedition 1 arrived on orbit in the year 2000, there have been more than 1,500 investigations active on the International Space Station in fields like medicine,
protein crystal growth, combustion, metallurgy, basic science, space science, Earth observation for disaster recovery and relief.
And many of those experiments and research projects have produced beyond the original intent. For example, a lot of the work in medicine was designed to keep astronauts safe in space, such as research on how to keep crew members from losing bone mass and weightlessness. And the researchers found that nutrition was playing a part.
The individuals had more iron storage in their body, had more oxidative damage, and had more bone loss in certain regions.
So, more attention was paid to providing foods with the right kinds of minerals and nutrients. Then, there was better exercise support, like an upgraded exercise device that proved its effectiveness in crew members who flew with it after having flown without it.
For the first flight, I lost 99% of bone loss. After the second flight, during all those prescriptions and exercises that I've been told to do, from bone loss perspective, I lost nothing.
The right combination of exercise and diet and vitamin D supplements meant no bone loss.
So there's been a huge development of our understanding of bone processes, why astronauts are losing bone, and how the bone remodels and recycles itself. Understanding that process helps us protect astronauts, but it also has the benefit of giving new insights into understanding those same processes on Earth, where so many people are worried about bone loss.
Another example of station research providing a benefit on the ground: water reclamation. Early on, the station crew members relied on space shuttles and other cargo ships to deliver fresh water. But the long-range plan was for a more self-sufficient station with a system that turns wastewater into pure drinking water.
On board the space station, we've had a water recovery system in use since 2008. This system recovers 90% of the water that we fly to the space station. This technology will be vital for our long-duration missions, and that's because on a deep space mission, the water resupply won't be practical.
And where else do you think this technology is proving useful?
The water treatment system that we developed for the space station has been deployed over the last 10 years now all over the world.
When you get involved with a plant of this kind, if it is well used, it can change the lives of an entire community. It gives you children that learn more. It gives you parents who spend less money on medicine. It changes the future.
And then there's space station activity that was designed to benefit people on Earth. For example, students on Earth, from grade schoolers through postdocs. Since the beginning, station crew members have used an amateur radio to talk directly with students on the ground, answering questions and inspiring some of them to careers in science, technology, engineering, and math fields. More than 500,000 students have learned about geography and teamwork and communications and problem solving by participating in an experiment that lets them control a camera on the station and aim it at targets on the Earth of their own choosing. The Spheres experiments originated to test algorithms related to formation flying, but it's evolved to include students in the design and execution of those robotic flights. The International Space Station has a lot of goals. Not only is it getting people of this planet to work together and enabling deep space missions of the future and seeding the growth of commercial space ventures, it has an ambitious agenda of laboratory science and technology research that's using the unique environment of low Earth orbit to learn what can't be learned here on the ground, to help people on the planet right now.
If you'd like to get another look at any of the stories we feature today, check us out on YouTube and on Facebook. There are the addresses in the friendly blue box. While you're there, though, look around at all the other stuff you'll find about NASA and America's human spaceflight program. And particularly, we've got a great 360 VR video that we shot in Kazakhstan during the last crew landing in February. Be sure to check that out today. If you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. Features folks here at NASA talking about their work and their personal experiences on the job. New episodes post on Fridays. Today, June 1st, my colleague Gary Jordan talks with astronaut Serena Onen-Chancellor about her upcoming first flight to space and the road she took to get to the launch pad in Kazakhstan. Go to www.nasa.gov/Johnson/HWHAP. Houston, We Have a Podcast. You'll find all of the episodes there. You can also listen to all of the episodes on iTunes and Google Play and SoundCloud. This is Mission Control, Houston.